Good evening, everyone. Welcome to this lecture. I'm Tony Symes. I organise monthly lectures for the Herschel Society, but this lecture has been given jointly with the BRLSI Visual Arts Group, convener John Law, and the title is the Jantar Mantar Astronomical Stone Observatory in Jaipur, and the lecturers are Richard Cox and Professor Mike Edmonds to my right. Please note this lecture is being recorded. For the housekeeping instructions, if you're in the room, if you hear the fire alarm, please proceed out the way you came in and keep right down Queen Square, right again at the bottom until you come to a small patch of grass on Chapel Row. We'll assemble there. An alternative exit route, if those stairs are all ablaze, is through the door at the back, through that room, and down the stairs to the entrance of number 18, and you can go out that way. And we have equipment for anyone who's too disabled to use the stairs, as the lift will be unavailable. For those of you who are on Zoom, please stay on mute and with video off during the lecture. You can turn your microphone and video back on for the Q&A session. You can put questions in the chat channel at any time. Questions will be dealt with at the end of the lecture. Now, looking ahead, our next event will be on Saturday, the 8th of June, and is an all-day conference on Sir John Herschel. Why John Herschel? Well, he's not famous for a single revolutionary discovery, like his father's discovery of Uranus, but he was active in many fields and became the most influential natural philosopher of the Victorian period. His importance in his time can't be underestimated, and learning more about him will illuminate the whole history of science in the 19th century. Back to tonight, and because we're crossing boundaries, we've got two lecturers. Originally, we had Richard Cox, and I'm going to leave John to introduce him. But because of the subject, we thought it would be really helpful to have somebody to answer questions on the astronomical side. And so, very kindly, Mike Edmonds, who's currently president of the Royal Astronomical Society, has managed to make time to be here as well. He's known for the breadth of his interests, including the Antikythera mechanism, and he's emeritus professor of astrophysics in the School of Physics and Astronomy at Cardiff University. He's vice president of our society, the Herschel Society, and I'm delighted he's willing to be here. But I'm going to hand you over to John to introduce Richard Cox.
Good evening. I'm John Law. I'm one of the visual arts conveners here at Brilsey, and I'm happy to introduce Richard Cox and his talk on the Jantar Mantar Astronomical Observatories. I've known about their existence for years, but I've never had the opportunity to visit, so I'm looking forward to learning about them this evening. Richard has sent a handsome catalogue of some of his images of the structures, and with his permission, which I've already got, I will donate this to the members' library here at Queen Square, so if anyone wants to look at it, it will be part of the collection. I hope you find this talk interesting. I'm sure you will.
I thought, by way of introduction, I would explain to you some brief history as to why I found myself working in India in the early 90s. After I graduated in the 1970s, for about 13 years, I worked both as a teacher in various different art colleges to support my practice as an artist, because I'm not an astronomer. I'm an artist who takes photographs, among other things. In the early 80s, I changed direction from teaching and joined a Regional Arts Association in South Wales, South East Wales Arts, where I had the good fortune to have a director, Hugo Perks, who gave me a lot of leeway to develop a program for the visual arts in South Wales. And over a 15-year period, I ran programs initially for them and then as a senior officer of the Arts Council. The centre of my programs was to do with placing artists in the public domain, an artist in residence program. And initially this was domestic. In the first years, it was based in schools and libraries, community centres. And then we branched out to a number of hospitals, forestry commissions, and other organisations where there was a sympathetic audience and an opportunity to work in dual with community people. In the late 80s or mid 80s, I had an unusual application from Japan, and we appointed a Japanese artist, and this led to developing the program with an international perspective. And this was achieved initially through twin arrangements. For example, Cardiff is twinned with Lugansk in the Ukraine. So the first official exchange we did was in Ukraine. And shortly after that, another one with Georgia, because Newport was twinned with Kutaisi in Georgia. We went on to work in Scandinavia and America. And the last program I set up was in 1993. My director at that time had asked me to organise a program with Barcelona. Now, at this time, the Arts Council had a major push because Barcelona was the international city of culture. It had the Olympic Games. Winchester College of Art set up an MA program there. You couldn't walk across the street without bumping into somebody creative. But at exactly the same time, a colleague of mine, a friend who was also an artist in residence in Philadelphia on my program, had just recently returned from India, where she had been traveling because her husband is part Indian and they were going to discover the place. Now, while she was in Jaipur, she ran into two senior lecturers at Rajasthan School of Art who were especially helpful and friendly and accommodating. And so when she returned, she was on my panel, she said, why don't we set a program up with Rajasthan, similar to the ones we've done with Philadelphia or Trondheim, whatever. And so I wrote to the British Council in New Delhi, to Shushma Bahal, who was head of sculpture. She had been in that position for a considerable time. And at that time, the only visual arts exchanges that were occurring between the UK and India were very high-profile, famous artists who were coming across, perhaps working with Cambridge University or the Museum of Modern Art in Oxford. And by the same token, the only artists that were going from the UK to India were going to a similarly prestigious thing. Now, the programme of Artists in Residence, which I ran, was principally aimed at what you might call mid-career artists. Let's just say people who have been out of college perhaps for 10 years, who are looking for new and interesting experiences, new places to work, new cultures to experience, something to broaden their perspectives and to provide them with opportunities. And because this was what I was aimed at, I explained in my contact with Shushma what I had in mind. Now, she was very helpful. I mean, she opened all the doors for me. When I arrived in Delhi, I had expected to meet perhaps a couple of small groups. It wasn't like that. But I wanted to describe to you my first experiences of India because they are etched in my mind. All the other places where I had been setting up programs had all in their different ways been very interesting. And it was a privilege for me to be able to do this. But India was completely different. I was standing in the big green area next to the House of Commons one day, eating an ice cream. And somebody behind me said, "You lucky bugger." And I turned around and it was Dennis Healy. He's about this much taller than me. And he was because I was eating ice cream. Now, I had recently read an article by him about India. And at the same time, I just published an article in Artist Newsletter. And we both used the same phrase. So India isn't a different country, it's a different planet. And it is. It's an extraordinary place. If you can imagine us arriving, it's 1:00 in the morning. It's 34 degrees centigrade. It's humid. there's a specific smell that I could identify immediately, and it was full of people. This is a new experience for us. Having got through customs, we then went through the exit, and Delhi Airport is not like this anymore now. And as we got to the exit, there were like 2 blocks of people, perhaps 150 people in each block, and a small path down the middle. And they were waving placards with people's names, and sometimes it was written in Hindi and sometimes it was written in English. And for a short time, we weren't quite sure what to do next. I say me and my wife, Alison. And at the end of the path, between the 2 blocks of people, was a white ambassador car. And there was a tall Sikh gentleman with a turban, and that was the British Council waiting for us at 1 o'clock in the morning. It was magic. And then we drove through the chaotic streets, even at 1 o'clock in the morning is, an experience to believe, and took us to our hotel. And I must tell you briefly about our first day in Delhi, because it was, again, we walked out into the heat. It was dry. Rickshaw driver who was outside our hotel, which was the YMCA Blue Triangle, Spartan but good. And we were going to drive to the Red Fort. But the Red Fort, we couldn't get in because there was a massive demonstration walking past it. So we went into Old Delhi, where we were told by our driver not to get out. And then we went to Gandhi's funeral pyre, which is an area of silence and quietness. And then we went to the British Council and met Shushma and her incredibly able assistant, Chandrika Grover. We then went to Jaipur. And in Jaipur, we met a large number of people. All had been primed carefully by Shushma and were all very interested in taking part. Now, this is my first slide. When you drive into Jaipur, this is what you pass. This is the Amber Fort. This is the old capital of Rajasthan. It's where Jai Singh II was born. And Jai Singh was born in 1688. And his father, Vishnu, died when he was only 11 years old, and he ascended the throne at that time. This is the man himself. Now, I've read a lot of texts, a lot of brochures, mostly which I bought in Jaipur, and there are a great many contradictions, sometimes in the same book. I could not find anywhere a reference to his physical size, but he must have been a big bloke, because in the City Museum, you can see his pajamas and his sword, and they are enormous. So he must have been much above average height. He was a very diligent scholar. He read extensively. He read mathematics. He read astronomy, which he became passionately interested in. And by ascending the throne at 11 o'clock, he had to take all kinds of duties on, but he always found time to develop his interest in astronomy. Now, in one of the most famous sites you're likely to see, or at least I'm going to point it, Jaipur is just here. This is an Indian map, so it's not very graphic. This is one of the most interesting and I think probably well-known images of a piece of traditional Indian architecture, built in 1799 by a great-grandson of Jai Singh II. And if you look at the top windows, you can see through the holes sky. This is because this building, which is the Wahar Mahal, the Palace of the Winds, it is single-skinned. It has no back. The reason being that the Maharaja's 57 wives could all sit in their own little balcony and they could observe street life and not be observed themselves. At the same time, when it's April and May and it's getting to be about 45 degrees, the wind will blow through the back. And this is like 18th century air conditioning. Oh, sorry, wrong way. This actually gives a more realistic idea of the colour of the building. It's called the Pink City. One of the reasons for this is that Prince Albert and Victoria were going to visit India because she was the Empress of India. And they painted the city pink in his honour. Unfortunately, he died before he ever got to see it. But it may be described as pink, but it's a kind of pastel brown. And as you can see, it appears on some stamps on Mansingh. And above this is the Samat Yantra, the small Tandar from Jantar Mantar. And this is the back of Jantar Mantar. And you can see just the top there and the back. And when you turn your back and look in this direction, you see Jantar Mantar. And the first thing you see is the great sundial. This is the biggest sundial in the world. The publications I've been reading ascribe to it slightly different dimensions. And it does vary, unfortunately. Many of the interpretations of the instruments I'm going to be showing you shortly, and which Mike is going to help me out with, have obscure interpretations. Some are clear and some are not. This is standing from the other end. One of our artists in residence, Vinay Sharma's brother, is an expert in this particular field. And when I printed this catalogue, I wrote to him and asked him if he'd write a chapter. Unfortunately, I couldn't get any response at all. One of the problems I have with some of the programs we used to run was that some people are not correspondents. And it's a shame because I would have appreciated his knowledge. Sorry, beg your pardon. Yes, Vinay Sharma's brother didn't respond, unfortunately. Now then. Right, now, bearing in mind the dimensions do change, I think these are fairly accurate. It is 44 metres long, it's 40 metres wide, and it's 28 metres high. The hypotenuse of the triangle is 50 metres to the base, and the gnomon is 2.8 metres wide. I wonder, Mike, if you could tell us a little bit about how it told the time and its accuracy.
Okay. Right. It's a sundial. It's a very big sundial. The whole of the astronomy in this complex, and in, as far as I can see, in the whole of Jantar Singh's astronomy, was to do with positional astronomy. It's to do to where things are in the sky. It's not a sort of astrophysics or even to some extent cosmological. It's a matter of finding and recording where things in the sky and having mathematical means then to predict where things will appear later in the sky, sometimes for astrological purposes. But the main sundial, obviously its main purpose is going to be, as a sundial, to tell time, basically, or at least fix time. And basically, you say you can see, if you look in the background, it's a sort of triangular thing. I'll show later where you can make one for yourself. But if you imagine that, does that look like the thing? Okay, imagine it's there we are. Okay, you imagine it's like that. Now, what you can't see on these pictures yet, but we'll see one in a minute. Either side, pushing out this side and going the other side, there's a curved surface. There, I can see it there. If you can you see the curved surface? And that's either side of that, what you call the gnomon, the main component. Now, either side is this circular, semicircular thing. Quite easy to do. In other words, when the sun is up, it will shine on this thing and the thing will cast a shadow. And you can see with the sun, as it were, behind my head, shining over the centre bit, it goes down onto this semicircle, on which on that semicircle, there is a scale, a graduation all the way along either side. So at any time during the day, you will find where the sun is from that position of the shadow on the semicircle. And you can guess what we call local noon would be when the sun is straight along the gnomon and you wouldn't have a shadow either side. So you can use it as a time-telling instrument. It won't tell you direct time. As you know, with a sundial, you have to really apply corrections if you want to relate that to Greenwich Mean Time or actual time. The actual effect of the Earth's orbit and various angles and so on is that it's not completely accurate all the time. You have to have corrections for the various motions of the sun. But it's quite an accurate instrument. You can also use it by sighting. If you sat yourself or stood, though it would be a bit hard in this one, we'll see it in other instruments, by the scale, you can sight other things along it. At night, you could try and sight stars. And from where they were along the gnomon as time went on, you could make some measurement of their position. But we'll see other instruments that measure position of things. So it's basically a big sundial. You can see the scale on the left there sweeping up, and you see the stairs the astronomer or the timekeeper would walk up to be able to measure where the shadow of the sun was falling. Okay?
That's great. Thank you very much. The original instruments, which were built in Jaipur between about 1724 and 1728, 1734, were made from limestone and from sandstone. And the graduations were inscribed into this, but they wore away. And also, when Jai Singh died in 1744, his eldest son, Ishvar, was not the least bit interested in astronomy, and in fact was involved with some internecine fighting. But he was succeeded by his brother Madho Singh, who was very interested in astronomy, and I'll be coming back to him later. The facing of the curves on the side, on which you can read, are in fact made of marble. But the marble was not contemporary with the original building. What happened was, when it was completed, and by the way, it was the second of, I should just go back a couple of slides. He didn't build one, he built 5 observatories. The first was in Delhi, which was completed in 1724. And the second was Jaipur, which was the largest, with 18 instruments. The Delhi one only has 4 plus 1. And he also built one in Ujjain, the sacred city of Ujjain, and Varanasi, which is Benares. I haven't been able to go to Varanasi yet, though I intend to on my next trip. But I have been to the others. The 5th was Mathura, but that was destroyed just before 1857. And it was sited within a fortress next to the Yuma River, but it no longer exists. Gives you an idea of its scale. You see the figures below. It is enormous. The restorations are there. This model is actually open to the elements. Interestingly enough, some of the best examples of the models from Jantar Mantar are here in this country. They're in the Science Museum, and I've seen a couple of them, and they're impressive. The 2008 was the last occasion which it went through major restoration. But the best and most important restoration took place in 1901, when another Maharaja, also called Madho, who was a distant relative of Jai Singh, took the restoration of Jantar Mantar at that time very seriously. Previous to this, it had been very neglected and fallen, not into ruins, but in very poor shape. It is important to point out also that Jai Singh, when he built these observatories, spent a huge amount of money on it. I mean, he really went absolutely to town and would have built more if he could have done. He certainly was very keen indeed. He wanted people to understand about astronomy. The next one I'd like to call Mike to help us with is Prakash Yantra. For my money, this is one of the most fascinating and most beautiful objects in the entire Jantar Mantar tradition. There are different versions of it in New Delhi and in Ujjain. These are two hemispheres upside, they are inverted the sky, and they complement one another, and they are so large that you can stand inside them. You're not allowed to do it now, but so you can read off the scale. Mike, can I invite you to have another go?
Okay, now these are rather difficult to describe. As you're saying, the dark bit is just a lack of surface. You can stand in them. Now the bowl, have you got another picture of the...
Yeah, sure. It's up to the...
I don't know, you swallowed it. No. Right. Okay, you can see the bowl. Do you have is there one with markings on? Perhaps the next one.
Yeah.
There we are. Inside these bowl is considerable marking. And I've puzzled a bit over this. Some of it is undoubtedly just straight solar, so you could use it in the same way as a sundial. What you have to do, you have to have something to cast a shadow. Now, I don't know if you can see. You can just see, can you just see a slightly lighter flying saucer?
Just there.
In the middle there. That's a little disc supported on across wires.
There's wires here and here.
Right. So that, when the sun is out, will cast a shadow of the disc onto the lines inside the bowl. And from that, from the markings on the bowl, you can read. You could obviously read angles, and what its angle was. I'll talk about some angles later on. But it's basically showing you where in the sky at that particular time the sun is. Now, the sun moves not only from side to side during the day, which you're familiar with, from east to west. You also know, of course, that the sun varies in how high up in the sky it is. Because in winter, as you know, it's low in the sky and goes from low in the southeast up a bit and then down into the southwest. Whereas in summer, it goes right from the northwest up in the sky and to the from the northeast to the northwest. Got to get this right. Okay. So there is a motion too, not only from east to west, but from north to south during the year. And the lines in here are a coordinate system that allows you to follow that to some extent. Now, it's also used for something else, which I still haven't completely fathomed at all. One of the most extraordinary things we've both tried, Richard and I, to find out more about how these things work. But we try as we might, we've found very little explanation, apart from the obvious things of how these gnomons and the major sundials work, as how these particular things work. Because they talk about being able to determine from this, what's called the ascendant sign, which typically would be when the sun is on the meridian, what is the zodiac sign that's rising in the east? Now, you may wonder, well, why the hell should you bother about that? But it has some quite profound implications for astrology. And a lot of this stuff is bound up with doing horoscopes and so on, and knowing where the sun is and what sign was rising over the horizon is useful. But how exactly this did that, I'm not entirely sure. You can follow the shadow, and there must be some lines that indicate this. I can imagine what happens is, as the sun moves from north to south during the year, different lines are illuminated during the day at different times of the year, and obviously different times as the sun goes across it. And those must be connected with which sign happens to be on the horizon that time, because that zodiac goes around the sky during the year. But exactly how they did it, I'm afraid we're still in the dark, but it must be something like that. Okay, the other thing you could use this one for as well, again, is to get planetary positions, because you could squat inside it at night and work out what the disk covered in the sky, and from that get some idea of the actual coordinates of an object in the sky, which might be useful.
Thanks very much. This is a close-up of two more dishes, very similar. In this instance, they're not cut into pieces, so you have access. Also, they're much smaller. Prakash Yantra was 5.5 meters across. whereas these are only 3 meters across. Very beautiful things, carved from marble. The major restoration work on this particular instrument must have been done in 1901 because on the rim, the date is there. But according to other texts I've been reading, the areas either side of the major sundial, which are faced in marble, beautifully cut, apparently were put in 1945. And so the marble work was done at 2 different times. It's exquisitely done, by the way. I mean, the precision and the quality of the craftsmanship is extraordinary. And you can read text here, but it's all in Hindi. These are called Kapali, by the way. Kapali Yantra. Jantamanta means it's an instrument for calculation.
Can I just point out?
Yes, please.
This one, can you see the actual shadow, which you therefore read off?
And there you can see, slightly out of focus, Kapali Yantra, and it gives the date 1901. The pair. So the major work on the restoration was done 1901, 1902. Interesting enough, assisted by a British Lieutenant Garrett. But additional work was then later done in 1945, and then the last restoration was in 2008 when I happened to be in India at that time. Now, these are the same instruments, the Prakash Yantra, but this is now in New Delhi. And these preceded the ones in Jaipur. And these were only done in limestone and sandstone. They did not have the marble. And as you can see, they deteriorate. What happens is that they are periodically repainted. But because the surface is limestone, none of the inscriptions can be read. And this would have been between refurbishments, really. This is very near the centre of Delhi, by the way, quite near Connaught Square. And you can see the stairs descending, so you can get inside and take a closer look. They're slightly smaller than the ones in Jaipur, but not much. I've done a series of photographs comparing different periods when I've been visiting. I tend to go back to the same places over a period of time and record the changes. Now, this particular instrument was not built by Jai Singh. It was built by Madhav Singh, who took the Hyderabad Maharaja in 1750, 6 years after Jai Singh had died. He was genuinely interested in astronomy. There are 2 very conflicting views from what I've read so far. It's called Mesra, and it is supposed to encompass 5 different instruments. Now, there is some of the writing that says that actually none of them work. It's a fascinating object to look at. I mean, people liked its look so much. It appeared as the symbol for the Olympics, and it has been used a lot. People have made cursory descriptions as to what its functions are, but I could not divine them myself. But it's undeniably a fascinating object. It's completely hollow, by the way. Many things that used to be stored in there. One of the Maharajas, who was complete dissolute, what happened was Jai Singh had made bronze models of Jantamanta before he built the large pieces. These were taken out of storage and melted down for selling of the bronze, which I think was tragic. What an awful waste. This is the Gnomon from New Delhi. It is a very large, but it is not as large as the one in Jaipur. And this was before it was being restored. It's a large site, but only with 5 instruments in it. You can see in the top right-hand corner there the back of Palace of the Winds. Now, what I wanted to look at next is Rashis, which are 12 signs of the zodiac. Each one is like a small Sumatra Yantra. I picked this particular one out because I happen to be born in Aries. And Mike, is there anything you'd like to add to these?
No, only that I suspect they were used for observing the sun when the sun was in Aries. That's what I can assume.
Yeah. I couldn't find an explanation.
Repeat what Mike says in the Zoom.
Sorry. I assume these particular ones they're assumed used for observing the sun when the sun was in Aries, in the sign of Aries, as it moves around the sky. These are much smaller. One thing I just comment very briefly, you may be wondering why these things are so large.
Yes.
It's not just that I want the biggest one. It's because if you're trying to measure positions on the sky, if you can make a very big instrument, you can measure accurately. If you imagine measuring an angle like this, can I use you a minute?
Yeah, sure.
Can you try and measure that angle near my chest?
How do you mean?
Yeah, that's it. So you can do that. Now, the same angle, though, further out. Try measuring it further out there, at the end of my hands. You see, how many hands could you get in there? 1, 2, 3, 4, 5. You could measure much more accurately there than you could here. So if you want to measure an angle on the sky, the bigger you make it, the easier it is to measure the angle. But you try and make a very big thing, it's more difficult to make it accurately.
Well, this shadow is...
Yeah, so you have to balance the two, but that's why they were big.
Exactly right. Yeah. This is the only slide I brought with me from Eugene, and it's slightly bigger than the small Summit Yantra, and much smaller than the giant one. The site in Eugene is rather run down and has only 4 instruments. So I've been concentrating almost entirely on Jantamanta in Jaipur, which is by a long way the best. The one I've not visited yet is the one in Benares, Varanasi. And the only image I've managed to find is actually an 18th century print, which gives you a clear idea of what it looked like. It's in rather poor condition, unfortunately, having seen some fairly recent photographs. One of the most beautiful objects, along with Prakash Yantra, I think, is the small sundial, Summit Yantra. It's beautifully made, and it has next to it a very simple device. It's a block of stone with a 27 degree angle on it and a groove. And if you sit at the base and look on the groove, it takes you to exactly where the pole star is. I very much like the simplicity of that. And this, by the way, was the first instrument that Jai Singh had built here by his Brahmin architect priests. And it's the first one in the series. This one was described as being abandoned. You can just about see, just there's a steel rod which projects outwards and will cast a shadow only at midday. And then these are graduated dimensions here, but it's described as being abandoned. By the way, this was taken during the refurbishment, and this was taken, a short time later. And this, like some of the instruments, actually is hollow. Mike, again, I'd be grateful if you could tell us a little about this one.
Very quickly, as far as I can tell, this is just simply an instrument mainly for measuring the azimuth of something. So if you stood in it and watched the sun go down or a star rising, you could get the direction around the horizon approximately, or at the height of the block there. So I think it was used as a device to measure around, whereas some of the other ones are measuring up. The one you just saw with the rod sticking out, that would tell you the elevation of the sun.
Sure.
And as I said, that would move backwards and forwards during the year. This, I think, is for measuring around.
If I can keep it there, this next one here.
Similar sort of thing, I guess, but I think it makes a rather nice summer house myself.
When I was photographing Janta Manta in the 1990s, it was possible to climb on these. And in fact, I stood on the steps here to take some photographs, getting an aerial shot. This is no longer possible. Not only have they built barriers around, like Ashiankara, for example, but there's an armed guard. And if you try climbing anything now, it's a waste of time, which is a shame in a way, but I sort of understand it. Now, I exhibited this work in 2018 at the Science Museum in London. And I think the pictures pretty much speak for themselves. And if we look at this one here, the reason I photographed Janta Manta was because it became an adjunct. I've been touring an exhibition since 2008, which is concentrated on a different aspect of traditional Indian architecture, about which I formed a lot of interest. In Rajasthan, there are approximately 2,000 wells. They're called step wells. The reason being that during the monsoon, they will fill up. And then during the period of the year, the water level will drop as it evaporates and as it is used. And in order to reach the water's level, you descend steps. This is a particular well in Ahmedabad, in Gujarat. Particularly fine example, 7 levels deep. I'm just looking on. And because of the collection of the Science Museum, they actually had the original architect's drawings from the 17th century of this particular well. And they were on display in a cabinet in the exhibition. It's about this book. It's about this book. It's a really large book. This is the first step well that I visited. When I was first visiting India, I received a huge amount of help and generosity from the people I was working with. They really made my life very easy. And during the course of the negotiations to set the exchange program up, this would have been 1993, 2 of the artists who were looking after me, so to speak, said, "We think there's something you'd like to see, you might find interesting." And they drove me 90 kilometers out of Jaipur along the Agra Road to a small village called Abrahani. And in Abrahani is this extraordinary well. It's called the Chandbari. And it was built around about 828. And it's an extremely unusual well because it is part Hindi and it is part Mughal. The Hindi architects designed it. If you can imagine a pyramid upside down, inverted, 100 feet deep with 13 levels, and each level with stepping on it. In the center, they built this structure here. Now, the center is Mughal, because when the Mughals arrived, they smashed up all sorts of things. The adjacent temple to this has been mostly defaced. All the figurative work, the heads have been smashed off. But the Mughals realized that this was a desert state and it needed water. And so they didn't try destroying the stepwells. And this particular well was a collaboration. It has both things. It is a national monument. And when I was first there, there were peacocks walking around. And around the sides are a colonnade of 94 chambers, each containing a sculpture. A well, when it is full, looks like this. It looks like a lake. You can't see the structure. This is in Bundi. Bundi is right off the beaten track as far as tourists are concerned. But there are 22 wells in the city, all built in the 16th century by the Maharina, who became interested in this. And obviously, if water drained out, you would see the steppings. This is also in Bundi, and for my money, it's probably one of the most beautiful wells in India. It's Ranji Ki Bauri, and it's a royal well. It's mostly made of marble. The elephants with their lifted trunk is a good luck symbol. And this is my wife standing on the side of it. It's 60 meters long, 40 meters wide, and 44 meters deep. It is a magnificent thing. And it is one of only 2 wells in all of India I've been to, and I've documented 300. You actually had to pay to get in. I think it was 10 rupees, which is like 10 pence. This just illustrates the stepping, descending as the water level drops. Most of my photographs taken between 1997 and 2004, it was possible to photograph the structures of the well because there was a 7-year drought. For 7 years, it hardly rained in the monsoon. So nearly all of the wells were empty. So it was possible to document the structures. And this for me is, probably is my favorite well. Also, it's my biggest earner. It was published in the National Geographic in 40 different editions. And they paid me a copyright fee for each one. And it's Panamina Karkund. It's a royal well. It stands just outside the walls of the Amber Fort, the old capital of Rajasthan. And it is an especially beautiful well. When I was a senior lecturer at Cardinal College of Art, I took student visits to India, and we photographed them sitting on the stairs. It's a wonderful place. And just half a mile from there is the Anoki Museum. If any of you end up going to India, don't miss it. I also showed this work at Jawahar Kala Kendri. Jawahar Kala Kendri is the second biggest art centre in Asia. It covers about 19 acres. It has 2 international scale galleries. It's got 3 small galleries. It has 2 theatres, one of which is outdoors. It has a museum. It has a restaurant. It has studios. And in sculpture, it has a sculpture court and a field. And in the field of craft, they have a village adjacent to it with about 40 dwellings where you can see people weaving and making ceramics. It's an extraordinary place. And it's about 4 kilometers from the center of Jaipur. This is a shot of part of a well, which I could only photograph with a telephoto lens because there was a 100-foot drop immediately below this. But it's one of the examples of the refurbishment. The image on the left is prior to it being refurbished, and the image on the right. And if you look carefully, just there, and there, and there, I nearly died because of not this well, but because of those hornets' nests. I was visiting a well which was blocked off, and you couldn't get access to it very easily. They built a barrier across it in Todala Rising. And I wanted to photograph the base of the well. And above the top of the well, about 80 feet up, there was a platform. And on the platform, you could lower a bucket. So I leant over the edge of the platform to photograph it, but there was a branch in the way. So I leant down and snapped the branch off, completely unaware that there was a hornet's nest attached to it. And I didn't know what to do. So I tried standing stock still. That didn't work. My hands were not covered, and my hat fell off, and they started stinging me. So I ran like hell. The local guide I'd picked up while I was there spotted what was happening. He was standing about 100 yards away, but he could see what was happening, and he could see me running. And the first hornet that stings you, and they sting you as many times as they like, sends out a pheromone, which says, "Guys, this is the target. and they were chasing me. And if you are stung by hornets more than about 14 or 15 times, you go into an anaphylactic shock. My guide saw what was happening. As soon as I got to him, he threw a blanket over me. We dived into the car and we drove the hell out of there. I was bitten 11 times. I was bitten on the neck, on the forehead, through my jeans and on my wrists. And it made me very careful in future, very careful, because I did encounter hornets many times more. But as long as you leave them alone, they're fine. But try attaching them home, and that's what happens. This is just this is a touring show. This is part of the exhibition when it was exhibited at Aberystwyth Art Centre. And a lot of the images I show are in pairs because they're photographed at different times to see how things are changing. This is an article I wrote for the Welsh School of Architecture at Cardiff University, showing Jan Barry. And you can see right at the bottom, oh, sorry, right. And that's the only water there, and it's just covered in slime. Sorry. I beg, forgive me. Yes, if you look at the base, the water is almost completely gone. That's the 13th story. It's the last story down. This is an article which was published by the Royal Geographical Society, and it shows Panamina Carcund, the well, which was also shown in National Geographic. And it gives you an idea of the scale if you look at the climber at the bottom left-hand corner. And these are some of the other wells I was documenting. This, sadly, this is Gully G. Gully G is in Bundy, and it's one of the many wells which have just fallen into disuse. Some you find, particularly in cities, are just been turned into rubbish heaps. But they are incredibly powerfully built. They were almost were earthquake resistant. I only found 3 wells which have been damaged by earthquakes, all in Gujarat. And to finish, I just wanted to thank and praise these 2 characters here, Rajiv Lalshan on the left and Shushma Bahal. Believe me, I could not have done half the things I did had it not been for the generous help of Shushma, who used her authority and her knowledge and her good humour to open all the doors for me and make my own. And Rajiv, who was at that time head of the MA department of Delhi College of Art, is where I was doing some visiting teaching, and he became the director of the Museum of Modern Art in Delhi and made some major important changes there. He is now retired. And these are the people I worked with. Their help, their generosity, they all worked far harder than I'd ever expect anybody to. And it's sorry about that. Sorry. Damn. Am I? Oh, sugar. What happened to the pictures of the people? Right. Sorry about that. Not every person in this were part of the exchange, but most of them were. And let's see. This is Ramavatar Soni. And he is actually one of the lower caste artists. Some of the artists I work with are Brahmins. He was a school teacher, but he made it his business to put himself out to help. He was one of our artists in residence. And the caste system, by the way, in India, there are 5 castes. But in India, there is one higher caste, which is Rajput. And Saga was Rajput. And one of the head of the Blue Pottery was also Rajput. We did a collaboration with Blue Pottery with ceramics. And one of the artists who went to work over there was the principal or the head of fine art at Bath Spa Academy. He's now gone to Danang. This is the last slide. A most recent collaboration where we've been touring what we call open books. They are books which are like concertinas, they open up. And illustration at the top is by Lalit Sharma just there. And he'd never made a book before in his life, and he made one of the best books in the entire exhibition. The show's been touring to China and America and Australia, and because of my contact with India, I took it there. Mike, your turn.
Okay, I won't detain you much longer. So, just the coordinate systems. This is just to frighten you and to make you realize what they were doing. As I say, it all has to do with plotting where things are in the sky, the positions of objects in the sky, particularly the sun and the moon, the planets, but also the positions of the stars, because they do vary. And over a considerable period, over 100 years or so, you will notice, if you make accurate measurements, what's called the precession of the equinox is a motion of the whole sky due to the way the Earth's axis moves. It sort of precesses around and it gives motion. But this is just to remind you of what coordinates are. When I talk about coordinates, you all, did it yours well. Longitude and latitude, everybody happy with that? Okay, longitude and latitude on the Earth. That's good, that's okay. Now, again, if we have the horizon around here, we can do azimuth, which is the angle around, and altitude, the angle up. Okay, so you could locate a star that way. Of course, that will change during the night, or from night to night, as the stars move. However, as you know, the Earth rotates, and there's the North Pole, and the Earth rotates as though the Earth had a skewer through the North Pole and through the South Pole. But that is not at right angles to the orbit of the Earth around the Sun. It's tipped relative to the orbit of the Earth around the Sun. That's what gives the seasons, variation of the seasons. So if we look in the sky, if I looked at the North Celestial Pole up the top here and the South here, this would be bent over on the Earth. Here's the path of the Sun around the Earth, if you like to look at it that way. It forms a path in the sky around the Earth. And if you wanted a coordinate system that moves with the stars, which if your altitude and azimuth is no good because the stars move relative to that, but you can have a coordinate system which is based on the North Celestial Pole and what's called the celestial equator, and then you can measure the position of a star by an angle called the right ascension and then the declination. Don't worry about the details. It's just a way of measuring positions on the celestial sphere. And it's these positions that the astronomers were after. This has always been true. In Greece, they were after this when in classical times, because you plot these and you learn, you've got a frame against which to measure the motion of the planets and so on. That's just the same thing again. That's the same thing again. This is what I was saying about the zodiac and the sign that you see. Oh, dear me. What did I do then? If you see here, here's the sun, here's the Earth going round. It looks as though the sun at any time is in a band around the sky where the zodiac signs are. The constellation's equivalent to that. And that varies during the year. It's 1 year around here. So, whoops, dear me, what am I doing? So when were you, Aries?
Yes, that's right.
Okay, so Aries is over here. So his birthday was when the sun was in Aries. So the Earth must have been round here, looking over that way, and that's where Aries would have been. Any other signs? Want to know where you were? Gemini. Where's Gemini? That's me. There we are. Gemini over there. So the Earth would have to be on the other side there to be in Gemini. And as I say, it is, well, yeah, it is. Yeah. Although, in fact, as you know, I mentioned that things precessed and changed a bit. In fact, since Greek times, they've moved at least half a sign, maybe a whole sign in the sky. Anyway, these things, as I say, for astrological purposes could be important as to what planet and so on, or what was on the ascendant on the horizon when you were born. Okay, I just thought I'd make it simpler by showing all the coordinate systems together. Okay, there'll be a test later. Right. Now, just for fun, if you want to take this a little bit forward, you can make a model of these things. For some reason, that the text has disappeared on this, but if you want to get these models, just Google paper model yantra mantra. All right. If you Google that, it'll take you to a page and you'll find these models. They look quite good. You just print them out on cardstock or on paper and make a model of them. And then you can work out yourself how they work. The only thing I'd just be careful of, if you're doing, do have a little prowl around the web to look at some things, be careful not to confuse seconds of time with seconds of arc. If you're measuring angle, you normally do that in minutes and seconds of arc, but time is in minutes and seconds of time, and it can be a bit confusing. I regularly get confused. Now, I just thought I'd show a couple of things of the shadows here so you can get the idea of the shadow. Here's the big one, okay, and there's the shadow of the gnomon on this marble thing you were talking about. And if we zoom on and zoom in, can you see the gradations? Now, I don't know, does it come across? It does just about out of the computer. Can you see the sun's shadow is here, or the shadow of the gnomon is actually there to that side? And what he's doing is using a little bit of wood to see if he can move that into the shadow, because the shadow, when the shadow of his little stick vanishes, he knows he's in the shadow of the gnomon. And you reckon these divisions, you can measure that to about 2 seconds of time. Okay, so now that doesn't mean you can tell the time to 2 seconds at any time, but it means that because you've got these various corrections you'd have to make, but you'll probably get the time to within about 10 seconds if you put the right corrections in using one of these, which, isn't bad. Not as good as a digital watch these days, but I don't think they had them then. So the whole things are fairly accurate. Now, I've just got one last slide I think I show. It's just one. This is, again, it's going to do a funny thing. You may have heard of Tycho Brahe. His dates are here hidden by Yai-Sing. Tycho Brahe was, for many years, was the source of positions of stars on the sky, regular observations. You can see he used a very similar sort of apparatus, the semicircle thing, but he's having the light of a star or whatever it is he's observing coming in there. He's observing to see where it is on the scale. He could measure positions with his instruments to about a half a minute of arc. Okay, at 360 degrees, 60 minutes in each degree, he could do about half a second of arc. And Jai-Sing's observatories are about the same, probably, of that sort of order. So they were as good as Tycho Brahe. What Singh was doing was trying to determine these positions so he could update his astronomical tables to do better predictions of what was coming in the future. They weren't really interested particularly in the world system. It was really about getting accurate positions so that you could do things like accurate horoscopes. Okay, but still doing, pretty accurate work. And as I say, Jai-Sing was as good as, I believe, as Tycho Brahe. There's quite a bit later. And it's the question is often asked, well, in astronomy, was he aware of what was going on in Europe? Because by that time, Tycho Brahe, and Copernicus and Galileo and something had moved away from a geocentric system to a heliocentric system, as you know. Now, in fact, for getting positions in the sky and positions of objects, it's easier normally to do it in geocentric than heliocentric. And essentially the Hindu and to some extent the Muslim traditions of astronomy carried on with that geocentric position. And we know that, I think you'll correct me on this, Richard, we know that Jai-Sing had a Copernicus in his library.
Yes, indeed.
Given to him by Jesuit priests, apparently.
Yes, indeed, and also Kepler and also...
Kepler and some Galileo stuff. Yes. But we've sort of talked about this. Well, hang on a minute. Was he really worried about it anyway? And are Jesuit priests going to give him a thing of Copernicus and say, this is the best stuff ever, seeing as it's forbidden by the Pope and, they're Jesuits? It's not going to be their favorite reading, is it? So what I suspect is that Jai-Sing may have heard that there were alternative world systems. Did he read Latin, do you know?
I don't know.
But because Copernicus
read Persian, Hindi, and Greek.
Yeah. Well, from the Greek, he'd have got a lot of stuff from Ptolemy and so on. That's well known. That went over into the Hindu astronomy hundreds of years before, probably from the time of Alexander the Great. But Jai Singh probably heard that they were these other world systems, but he wasn't really probably very interested. What he wanted was these accurate numerical values of where the stars were and where the planets were, so that he could do better further calculations. And I'd say it's missed off the bottom here. Things didn't get better than this really until Flamsteed, the first astronomer royal, around 1700 or so. And with the quest for longitude measurements and so on, that's really then that everybody started tightening up the way they did things. Flamsteed could do positions probably to about, well, certainly 2 minutes. And by the time it worked, he was getting positions to a few seconds of arc, much better than Singh would, or Brahe before them. But they're not bad for what their purpose was. These were pretty good instruments. But most, well, I think Richard has copiously shown this. The thing about these objects is they're beautiful. They're real monumental works of art. They were scientific instruments, but not many scientific instruments look that good these days.
Excellent. Well, I want to thank Mike for his invaluable work. This guy, I don't really understand all these things work, but I do think they're extraordinary looking. And I think if there are any questions, we'll do our best.
We have 2 roving microphones here, so if you put up your hand, you need to speak into the microphone right into it, you see the audience. I've got a question here.
Mike, you talked about making the corrections. In essence, you can only know about the solar analemma if you've actually got a clock. That is a way of determining time independent of the Earth's rotation. So did they have a mechanical clock?
I don't know whether they would have had at that time in India. Probably, possibly. Did he have clocks in his library? I seem to remember some mention of his, but I mean, a lot of this so long as you observe consistently, you can set up your own timing frame. I agree if you're going to do easy stuff, it's much easier if you've got a clock there and you can do your analemma and whatever it is. But a lot of the corrections, I remember the Greeks didn't have a clock. Well, they had water clocks, so you could use a water clock, I guess, if you were doing some observations, and they had sun clocks because it's a sun clock. But you can still do quite a lot just observing without a clock. It's better if you have one, but it's not impossible to do stuff. You're not going to get your latitude and your latitude without a clock. But you still can do quite a lot of detailed work without one. Because you have to set the clock. I mean, the clock is useful for timing device, but you always have to have a way of setting the clock at noon or whatever and checking that it's going from noon to noon in the right span and so on, for which you would use a nice sundial, basically.
Hello. I come from India, and every child that's born, in India has to have a horoscope, because the time has to be very accurate. And also the importance of the horoscope is the effect of all the waves from all the astral bodies that will determine the brain, how the brain will progress as the child grows. So the measurements in the skies had to be extremely accurate. And with regard to your what you said about the geocentricity of the measurements, actually it was in India that they concluded, through observations over several millennia, that not only is the universe not geocentric, it's not even heliocentric, because all the objects that were observed to move over all the millennia seem to indicate that there were separate centers, focuses. So that that would be reflected in the changes that happened over millennia, adjustments to be made. So when I visited the Jantar Mantar last year, exactly 1 year ago in May, I went to the Jantar Mantar in Delhi, and I've got photographs from there. they were actually trying to explain how the steps that went down actually took account of the shift over several millennia of the different centers around which the zodiacs, would move, because each galaxy would have its own center. And I found that so interesting and complicated and I was very impressed that the guide actually understood all the mathematics behind it. So, to talk about Copernicus, because Italy had connections, it has a very wide coastline, so they were very prone to influences from both east and west, and so on and so forth. So the concept of the center of the universe not being the Earth moved to Italy, but was suppressed by the Vatican because it conflicted with the teachings there. So actually, Copernicus was, I think he was, his head was knocked off, was it?
Galileo was the guy in Italy,
right,
who held to the Copernican system. Copernicus was Polish and worked in Poland.
Oh, right.
Although he did actually visit North Italy early in his life.
Right.
It was Galileo who was saying Copernicus' system is right, and the Pope didn't like that, as you said.
Yeah.
And he was shown the instruments of torture and said what happened to him, and he suddenly decided, oh, okay, it's all right, yes, it goes around the sun. But he was
right. Yes.
You know the famous story as he got down from the stand, he said, yes, it bloody does go around.
So my horoscope, when it was made when I was born, actually depicts. It's got pictures. It's sort of like a scroll. It reams. You unroll it, and in the middle there's a picture of a woman with an elbow stuck in the belly, an arm out. But it was sort of representational of the universe. Basically, I didn't understand it, and I think it's lost now. But I just thought I'd make you aware.
Thank you.
It's just a remark, really. I visited the Jaipur Jantar Mantar in 2012, and I think you said that it had undergone a restoration just a few years before.
Yeah, Richard.
So it was in a very fine condition.
Yeah, that's right.
I was, I didn't expect the aesthetic attractiveness of it and the evident very high quality of the workmanship.
I couldn't agree with you more. It's one of the things that attracted to me so much when I first saw it, and why I have repeatedly gone back to it. And the restoration in 2008 was done wonderfully well.
Yes, and I got a guide to it, and I do remember I couldn't find it, of course, when I was coming. The guide said that Jai Singh had a collection of fairly up-to-date Western astronomical instruments.
That is true. He actively encouraged people to come and visit his site when it was built, particularly from Portugal, because as Mike was saying earlier, it was said that a Portuguese Jesuit brought the works of those three to him. But as I say, I have alternative texts which say quite the opposite, because it was heretical.
What struck me at the time was that, of course, Tycho Brahe's observatory on the island of Hven between Denmark and Sweden in the Øresund. Well, it doesn't exist. He was thrown out by the peasants for ill-treating them. And
oh, really? What year would that have been?
But it struck me that this was what it would have looked like had it remained in place. But it's the nearest thing to Tycho's observatory.
That's his.
Yeah. So it made a very great impression on me.
You and me both.
Right. So on the chat channel, We have a question that says, in the West, we're led to believe that we discovered and interpreted the cosmos. How important internationally was this site during its heyday and since?
I think at the time, he attracted a great deal of attention. But according to some of the texts that I've been reading, it fell into misuse for a longish period of time before it was revived. So I certainly some of the texts say it did not have a great long-term effect. But I think at the time it was done, there was a lot of interest because a lot of people traveled from Europe to see it and to meet Jai Singh and to learn from him. So I think it was localized at the time, but later on it fell into disuse. Do you know, is that correct?
No, I don't know, but I would guess what you're saying is correct.
Yeah. And just the trouble is, as I've said one or two times before, the different texts I've been reading can be contradictory and make alternative views.
By the way, if anybody wants to, I have full instructions here of how to build. First, on ground leveled with water, right, standing in channels, draw a circle of desired radius. On this circle, draw north, south, and east, west lines. Excavate a concave pit within the circle. Cut out a semicircle of wood or metal of the same size as the circle. This is from one of your, the circle ones. And there's a whole thing about how to build it. Right. So if any of you want one for your garden, we can supply the...
I didn't get why he built several of them, because they are a huge enterprise individually.
Yeah, it's a very good question. It's very good. Why so many?
Because they weren't very far apart.
I suspect it because he wanted to find out which was the most accurate. It was a matter of probably trial and error until... Is that what your guide said, that he tried different things? Wait for the microphone, please.
What the guide in Delhi said is that although the steps, the thousands of steps that run down the curved sort of sides are very accurate, the position does make a difference. So the 5 different positions of these 5 different locations at which these instruments were produced or created, or constructed would help the calculations because
and they did also do slightly different things. I mean, the one you said they weren't sure if it worked with the little poles sticking out, but it would be good at measuring the height of the sun at midday. That would probably give you a much more accurate value of the height of sun at midday than maybe using the ordinary gnome onwards. So, they were different ones for different things, but I suspect some of them did the same things, but he was experimenting probably to see which worked best, which were easiest to use. And a remark I've read, but I haven't explored, is that you wouldn't necessarily use these all the time. You'd use them for doing particular measurements. It wasn't like sort of an observatory today where you spend every hour you can observing all sorts of different things. They had particular purposes, particular programs, but it wouldn't necessarily be every instrument continually in use. You'd have used maybe that one next week. That one we'll use in August, see how it works, sort of thing.
The path of the Earth around the Sun is not actually circular, is it?
No, it's elliptical, and hence some of the problems with the speed of the sun. The speed of the sun goes through the sky. That varies over the seasons.
And who managed to establish what the deviation was?
Well, the Greeks,
sundial.
The Greeks knew it very well, and a lot of their observations went back to the Babylonians. So almost since prehistory, the fact that there was a variation, that it was known for many years, for a long time ago, and I don't know how far back. I'd guess certainly, probably maybe even pre-Babylonian, that what do you call them? The time from equinox, the seasons, the astronomical season, time from the vernal equinox to the solstice, to the equinox, to the solstice, are not equal. They vary slightly by about a day or a bit more. And that's because of the ellipticity of the Earth's orbit. So it would be interpreted not as the ellipticity of the Earth's orbit, but the way the sun goes around the Earth is right. But that was known back in the Greeks and Babylonian times.
Oh, hello. Is this on? Good. I was very lucky to spend a week out in Jaipur in 2011 as a guest of somebody called Vimal Sharma, who's a doctor working in the northwest of England. And I went out as his guest because it was a medical conference. It went on for a week. And his brother, of course, is Sharma, who is the head of the observatory. So we met him virtually every day, and we had a couple of days there. It was absolutely the most fascinating, beautiful place you can ever wish to go to. I heard the version that you gave, that this was very heavily influenced, the design and the build of it, by Portuguese and possibly by Dutch advisors, because Jay Singh was very impressed with Western astronomy and wanted to have as much accuracy as possible, not to become an astronomer, but become an even better astrologer. Mm. And the real importance of this site.
Hold the microphone up a bit.
Okay, the real importance of this is astrological. Hello, is that better? Right. The whole point of this thing is to be the most accurate astrological instrument in the world. And I think it probably still is, because Professor Sharma, spent a lot of time in the Middle East and the Far East, personally casting horoscopes for very senior people around the world. I did ask him if he still used the observatory to help him with his astrological predictions. He said, "Oh, good God, no! I use my laptop now." But I think the important thing is that it's a thing of great beauty, but it's an astrological thing rather than an astronomic thing in terms of its meaning. And there are, of course, 12 small gnomons for each of the astrological signs around the site. But it is staggeringly beautiful. And thank you so much for reminding me what a wonderful time we had that week. And I have to say the medical conference was absolutely fascinating as well.
Well, we've come to about the end of our time, and there seem to be no more questions. So I think it's just remains for me to say what a delight it's been to hear and see art and science combined in this way, and these extremely elegant structures, when they were built and what they meant. I mean, I've learned a great deal this evening. So let's put our hands together for both our speakers, please.